All right, starting lesson 6.2, radicals and rational exponents. Okay, there's quite a few properties you have to understand here, and there's little details that you have to pay close attention to. All right, so here we're talking about radicals. All right, so here's a radical. And what is this? This is a radical right here. And what's this little number here? That represents the root to the radical. So in this case, it's the nth root. And radicals are simply taking a value and raising it to a power that's a fraction. So that's where radicals come from. Okay, so radicals are essentially fractions that are powers in disguise. All right, for the next couple of properties, if your n is even, the root is even, all right, when you take the even root of a number, you always end up with a positive and negative result. And if you take the root of 0, it's simply 0. And if you're taking the radical or root of a number less than 0, or in other words, a negative number, you can't do that. So there's no solution. All right, example 1, let's apply some of these properties. Find the indicated real nth root of a. Okay, so they tell you this information here. We have negative 27. And they're telling you the nth root. Well, what's n in this case? 3. So it's the third root. So there's my radical, and my root is 3. All right, so when you set it up in this way, all you need to ask yourself is what times itself is negative 27. In other words, what can you multiply by itself 3 times to end up with negative 27? That would be negative 3. All right, negative 3 times negative 3 times negative 3 is what? Negative 27, right? So that's what it means to take the third root of negative 27. How many times can you multiply a number by itself? 3 times to end up with negative 27. All right, and that value is negative 3. All right, here we have n equals 4 and a equals 16. All right, here's 16, and I'm taking the fourth root of 16. So what times itself is 16? Well, that would be 2. All right, that's all there is to that. But let's not forget, whenever you take an even root of a value, you end up with the positive and the negative. All right, so your answer here should be positive and negative. Don't forget that. All right, go on to the next example. All right, evaluate each expression. All right, so here we have the third root of negative 8. So what times itself is negative 8? Well, that would be negative 2. All right, and what do we have next? All right, notice that the negative is outside here. So you don't mess with that till the very end. So what times itself is 8? Well, 2 times 2 times 2 is 8. So I have 2, but then I had this negative outside here the whole time. So I got to make sure to attach that at the end. All right, now here I have 16 to the 1/4 power. All right, now it's important to know how to translate this fraction power into a radical. So it's going to be a radical, and your denominator here represents the root to the radical, 4. All right, and the numerator on top is the power of the 16. All right, so essentially you're taking the fourth root of 16. So what times itself is 16? That would be 2. And for the next one, here I have negative 16, and I'm taking the fourth root of it. All right, now this is an important question. Can you take an even root of a negative number? No, you can't. So there is no real number here as your answer. All right, going on to the next example. Rational exponents. All right, this simply shows how you're just converting, going from one form, breaking it down into another. All right, so simply, whatever the denominator is, once again, that's your root, and whatever the numerator is, that's simply the power on the outside. All right, and here's just a example of that. All right, so evaluate 16 to 3/4 power. First example, let's translate that into radical form. So I'm going to have 16. What's my root? My root is 4. And then this whole thing is to what power? The third power. So first off, what is the fourth root of 16? What times itself times itself times itself is 16? That's going to be 2. So then I have 2, and I take that and raise it to the third power, and I get 8 as my final answer. All right, pretty simple once you get the hang of it. All right, we also have part B here. So 27 to the 4/3 power. So I take that, and what's the root of this? The root is 3. And I'm raising the whole thing to the 4th power. So what times itself is 27? That would be 3. So I have 3, but I still have to raise it to the 4th power. So 3 times 3 times 3 times 3 is 81. Done. On to the next example. All right, let's do a couple extra examples to finish off the lesson. Say you had something like this. You're raising it to the half power. How would you simplify this? All right, well, essentially, I'm taking the second root, or the square root, of both the numerator and the denominator. Okay. Or if that doesn't make sense to you, essentially this is what we did in the very beginning. All right, the whole thing was square rooted. All right, but you could break it up into parts. So what's the square root of 1? Well, what times itself is 1? That's simply 1. And what's the square root of 25? Well, what times itself is 25? That's 5. All right. So that's all there is to that. All right, so really simple idea once you get the hang of it. You have to know how to transition from one form to another. For example, if I have this, you should know that this means this as well. And going backwards as well, you should know that this means this. Okay, and once you're able to convert from one form to the other, it makes it really easy to do. All right, if you have any questions, make sure to ask. Begin the assignment at the bottom of the webpage.